Data analytics is the rigorous scientific discipline of transforming raw data into actionable insights, employing systematic techniques to uncover patterns, trends, and correlations that drive informed conclusions and strategic decisions. Decision tree analysis is a powerful visual decision support tool that maps out complex choices, potential outcomes, and associated risks in a structured, branching format resembling a tree. Each node represents a decision point, chance event, or outcome, allowing analysts to evaluate different paths based on probabilities, costs, and benefits. By quantifying uncertainties and illustrating consequences, it enables data-driven decision-making, risk assessment, and strategic planning, turning ambiguous scenarios into clear, actionable roadmaps for optimal results. Root cause analysis is fundamentally about tracing a chain of events and identifying the sequence of failures and contributing factors that lead to an undesirable outcome. It's not just about what went wrong, but why it went wrong. This method helps us move from reactive troubleshooting to proactive prevention. In this process, it's important to distinguish between causal factors and root causes. A root cause is the underlying issue. Removing it would prevent the problem from happening again. In contrast, a causal factor may influence the outcome, but eliminating it alone wouldn't guarantee the issue won't recur. Understanding this distinction allows teams to focus on changes that will truly drive long-term improvement and system resilience. Carrying out a systematic root cause analysis involves choosing the right method for the situation at hand. Common techniques include the 5 whys, fishbone diagram, bowtie analysis, and fault tree analysis. Each offers a structured approach to uncover the underlying reasons behind an issue, helping teams move from symptoms to solutions. The key is selecting the method that best fits the context. For example, fault tree analysis is ideal for high-severity incidents where a detailed and logical breakdown is needed. On the other hand, the fishbone diagram is great for collaborative settings. It encourages brainstorming and captures multiple potential causes across categories like people, processes, and materials. Choosing the right method ensures the analysis is both efficient and effective in driving meaningful corrective actions. There are methods and guidance on choosing the best root cause analysis techniques, such as: Number 1, the 5 whys technique is a simple but powerful method where you repeatedly ask why, usually 5 times, to drill down into the root cause of a problem. It helps uncover the underlying issues behind a failure by asking why an event occurred, then questioning the response, and continuing the process until the root cause is identified. Steps to conduct 5 whys. First, identify the problem. Define the issue that needs to be addressed. For example, the machine broke down. Ask, why did the machine break down? The belt broke, for instance. Continue asking why. For each answer, ask why again. Continue asking why until you reach the root cause, typically after 5 iterations, but sometimes more or less. Why did the belt break? Because the belt was worn out. Why was the belt worn out? Because the maintenance schedule was missed. Why was the maintenance schedule missed? Because we don't have a clear maintenance protocol. Identify the root cause. After asking why repeatedly, you should have uncovered the root cause. When to use 5 whys. Best for simpler problems or when you don't have a lot of data to analyze. Effective in team settings, particularly for issues with a single cause or when you want to quickly identify the underlying issue. Number 2, fishbone diagram, also called Ishikawa diagram or cause and effect diagram. The fishbone diagram helps visualize the many possible causes of a problem. It looks like the skeleton of a fish, with the head representing the problem and the bones representing various categories of potential causes. Steps to conduct fishbone diagram. Define the problem. Write the problem statement at the head of the fish. Identify major cause categories. Create categories for the potential causes of the problem, often grouped into areas like people, human factors, skills, training, etc. Processes, workflow, procedures, etc. Machines, equipment or technology issues. Materials, inputs or raw materials quality issues. Environment, external conditions like temperature, weather, etc. Measurement, issues with data collection or analysis. Brainstorm possible causes, have the team brainstorm potential causes for each category. Draw the diagram, connect each cause to its respective category, that is the bones of the fish, creating a visual representation of the problem's possible causes. When to use, best in a team setting, especially when multiple factors or team members are involved in the problem. Ideal for problems with multiple potential causes and when a thorough analysis is needed. Number 3, bowtie analysis. Bowtie analysis is a risk management technique that visually maps out how a risk event can occur and its consequences. The diagram looks like a bow tie, where the central knot represents the risk event, and the left side outlines the causes, while the right side outlines the consequences. It also includes control measures to prevent the event and mitigate the consequences. Steps to conduct bow tie analysis. Define the risk event, identify the central event, for example, machine failure. Identify the causes on the left side, list the causes that could lead to the risk event. Identify the consequences on the right side, outline the possible consequences if the risk event occurs. Identify controls, determine preventive measures on the left side to reduce the likelihood of causes, and on the right side, identify mitigating controls to minimize the impact of consequences. When to use, effective for high-risk or high-severity incidents, especially those with a clear central event that could lead to serious consequences. Also, useful in complex or high-impact scenarios, such as safety-critical incidents in industries like aviation, energy, and healthcare. Number 4, fault tree analysis FTA. Fault tree analysis is a more systematic and mathematical approach to identifying the root causes of failures. It is a top-down deductive method that involves diagramming possible causes of an undesired event in a hierarchical, logical structure. It starts with the top event and traces back through branches to identify various contributing factors. Steps to conduct fault tree analysis. Define the top event, clearly identify the undesired event, for example, machine failure. Break down the problem, identify the logical relationships that could lead to the failure, mapping them in a tree structure. Each branch represents a potential cause. Identify contributing factors, continue breaking down the causes into more detailed elements, using and/or gates to show how different factors combine to create the top event. Analyze the tree. Once the tree is built, analyze each factor and identify the root causes. When to use. Best for complex systems or high-severity incidents where a precise and methodical breakdown is needed. Suitable for technical fields such as engineering, aerospace, or nuclear industries, where failures need to be prevented by understanding exact relationships. How to choose the best method for RCA. For high-severity incidents, like catastrophic equipment failure, safety incidents, fault tree analysis is the best approach as it provides a detailed, logical breakdown and quantitative analysis. For team brainstorming and when multiple factors contribute to a problem, fishbone diagram is ideal as it allows team members to collaboratively explore all possible causes. For simpler, straightforward problems, the 5 whys method is quick and effective, allowing for a direct identification of the root cause without needing extensive data. For risk events that involve both causes and consequences, bowtie analysis is best suited for mapping out both preventive and mitigation measures in a clear, structured way. In conclusion, the right method for RCA depends on the complexity of the problem, the severity of the consequences, and the available data. In general, high-severity incidents or complex systems are best suited to fault tree analysis. Team-based settings with brainstorming are most effective with fishbone diagrams. Simple problems that require a straightforward analysis benefit from the 5 whys technique. Risk events with clear causes and consequences should use bowtie analysis. By selecting the appropriate RCA technique, you can systematically identify the root causes of issues, mitigate their recurrence, and improve overall system performance. Measuring critical performance, processes, and goal achievement is essential for tracking progress and ensuring organizational success. Key performance indicators are used to evaluate how well objectives are being met. It's important that these KPIs are clearly understood by the staff involved, and that they know the corrective actions to take when performance deviates from targets. Setting SMART objectives, specific, measurable, achievable, relevant, and time-bound, creates effective KPIs that provide clarity and focus. Additionally, it's crucial to fully understand your metrics and ensure that the targets you set are realistic. This approach ensures that your KPIs guide your team toward success and continuous improvement. There are different types of KPIs, each providing valuable insights at various stages of performance monitoring. Lag indicators are outcome measures based on historical data. They are precise and can be easily calculated, but they are often only detected after issues or damages have already occurred, making them more reactive than proactive. Lead indicators, on the other hand, are performance drivers that help predict future outcomes by identifying early signs of a potential change. While these indicators are usually rough estimations, they offer an early warning that allows for proactive actions. Current indicators measure performance as it happens in real time, providing immediate feedback on ongoing activities and helping to adjust actions as needed. KPIs provide significant benefits by measuring how well systems are performing and offering insights into the effectiveness of strategies. They act as a guide to define the corrective actions needed when performance is not meeting expectations. Additionally, KPIs play a key role in financial performance and control, ensuring that resources are allocated efficiently. They also contribute to employee motivation, as clear performance targets can drive focus and improvement. Effective KPIs possess several key characteristics: clarity, ensuring that everyone understands what is being measured; relevancy, making sure the indicators align with organizational goals; and credibility, ensuring that the data used is accurate and reliable to support decision-making. A good metric possesses several key characteristics. It should be comparative, allowing you to measure progress relative to other factors or benchmarks. It needs to be understandable, ensuring everyone involved can interpret it clearly. Rates or ratios make metrics more actionable and easier to work with. The best metrics are also easier to act on and should inherently drive behavior change, helping to guide decisions. Moreover, a good metric is inherently comparative, often useful for comparing opposing factors or outcomes. To create better KPIs, follow these 4 steps. Start by brainstorming possible metrics. Then, combine those metrics to form new ratios or rates for more insightful comparisons. Afterward, select a limited number, ideally 1 to 3 of metrics to set as your KPIs. Ensure they pass the vanity test, meaning they measure what truly matters and not just superficial data. Finally, consider creating new metrics by combining 2 different metrics into a ratio or rate for deeper insights. Document analysis is a methodical process of reviewing and evaluating both printed and electronic documents. This technique is often used to extract project requirements by analyzing existing documentation. It's considered a qualitative research method, where data is carefully examined and interpreted to uncover insights, gain a deeper understanding, and ultimately draw conclusions that inform decision-making. By systematically reviewing documents, project teams can gather valuable information without the need for new data collection, making it an efficient way to ensure that requirements are thoroughly understood and met. New project requirements can be derived by carefully analyzing existing documents. Key sources include business plans, which outline the strategic direction and objectives that can guide project goals. Service agreements provide details on customer expectations and contractual obligations, which may shape deliverables. Marketing materials offer insights into market positioning and customer needs, helping to define the project scope and target audience. Additionally, reviewing current process diagrams can reveal areas for improvement and optimization, while application software documentation provides technical specifications and constraints that will influence the project's design and functionality. By extracting information from these documents, you can build a solid foundation of project requirements. Simulation is a model that replicates the operation of an existing or proposed system, offering valuable insights for decision-making. By testing different scenarios or process changes within a controlled environment, Simulations provide evidence to help anticipate outcomes and make informed choices. Common examples of simulation models include weather forecasting, which predicts atmospheric conditions, and flight simulators, which are used to train pilots by mimicking real-world flying conditions. These simulations help in understanding complex systems and evaluating the impact of various variables before implementing real-world changes. A burn-down chart is an essential tool used by Agile teams to track the progress of a project by displaying both the work completed and the work remaining within a specific time. It helps teams visualize how much work is left to do and predict when the project will be completed, allowing for better planning and adjustments if necessary. The iteration burn-down chart specifically focuses on the remaining unfinished work within a single project iteration. It's a graphical representation that not only shows the progress made but also projects how much work is left, helping teams stay on track and ensure they meet their iteration goals. A SWOT analysis serves multiple goals for an organization, helping to evaluate its current environment and identify emerging needs. It is a powerful tool for recognizing barriers to success and developing actionable plans to overcome them. Additionally, a SWOT analysis allows teams to adjust or redefine plans as new needs arise throughout the project lifecycle. By identifying areas of strength, organizations can leverage these to implement new strategies more effectively. It also helps to develop clear criteria for evaluating project success and assessing market performance of products or services. Moreover, SWOT analysis highlights weaknesses and risks that could jeopardize project goals, allowing teams to develop strategies to address and mitigate those threats. Strengths are the tangible and intangible assets internal to the organization that provide a competitive edge, including human expertise, robust processes, financial stability, innovative products or services, and strong brand loyalty. These elements form the foundation of the organization's capability to execute its strategy and achieve its objectives effectively. In contrast, weaknesses are internal limitations or deficiencies that hinder performance and place the organization at a disadvantage relative to competitors, such as outdated technology, skill gaps, inefficient processes, or poor customer perception. These factors detract from goal attainment and must be addressed through strategic improvement, investment, or transformation to mitigate vulnerabilities and align internal capacities with external opportunities and demands. A SWOT analysis systematically evaluates strategic positioning by examining internal strengths and weaknesses alongside external opportunities and threats. Opportunities represent attractive external factors, such as market growth, technological advancements, or industry consolidations, that the organization can leverage to advance its mission and expand its influence. These arise from favorable conditions in the environment and require proactive recognition and planning to capitalize on effectively. Conversely, threats encompass external elements, including competitive pressures, regulatory changes, or economic shifts, that jeopardize reliability, profitability, or even the organization's survival. These uncontrollable risks compound vulnerabilities and demand vigilant monitoring and mitigation strategies. By contrasting opportunities and threats, the SWOT framework empowers leaders to align internal capabilities with external realities, turning potential challenges into strategic advantages while safeguarding against disruption. Regression analysis is a statistical method used to understand and quantify the relationship between two or more variables. It helps businesses estimate the value of a dependent variable based on the known values of one or more independent variables, allowing for informed decision-making and predictions. In the context of software testing, regression testing is performed to ensure that updates or changes made to a system haven't introduced new defects in existing functions. This type of testing is crucial for maintaining system integrity and verifying that new code does not negatively impact the overall system performance. Cost of quality is a methodology used by organizations to assess how their resources are being allocated to various activities aimed at maintaining and improving quality. COQ helps organizations understand the costs associated with ensuring high-quality products and services by focusing on three main areas: Prevention, resources spent on activities that prevent poor quality from occurring in the first place. Appraisal, resources dedicated to measuring and evaluating the quality of products or services. Failure, the costs resulting from both internal and external failures, such as defects or issues that arise after products have been delivered. By understanding these costs, organizations can make more informed decisions on how to allocate resources effectively to improve quality. Make or buy analysis is the process of gathering and organizing data related to product requirements, then analyzing these requirements against available alternatives, such as purchasing the product externally or manufacturing it internally. This analysis helps organizations evaluate the best option based on factors like cost, quality, and time. Make or buy decisions are decisions made when determining whether to produce a product internally, which is the make side, or purchase it from an external supplier, which is the buy side. These decisions consider various factors, including financial, operational, and strategic considerations, to choose the most cost-effective and efficient option.